Hello everyone. In today's video, we will see the first property of the discrete Fourier transform, that is linearity property. The statement of the linear property says that DFT of a1 into x1 of n plus a2 into x2 of n should be equal to or is equal to a1 into capital X1 of k plus a2 into capital X2 of k. Now, let's prove this property using the discrete Fourier transform formulas. Now let's take left hand side, that is DFT of a1 into x1 of n plus a2 into x2 of n. Now to the right hand side, this is our input and we have to prove this. So if we see the formula of the discrete Fourier transform, here using this formula we will write the right hand side. So summation n is equal to 0 to n minus 1. In the place of x of n means input and our input is this itself. This is our input. So in place of x of n, we will put this one. So a1 into x1 of n plus a2 into x2 of n into remaining part e power minus j 2 pi by n into kn into e power minus j 2 pi by n into kn. Okay, we have substituted input in the formula, right hand side of the formula. Now let me write right hand side here. I will take a1 outside and apply summation to the input. So x1 of n into e power minus j 2 pi by n into kn plus, now again I will take a2 outside and apply summation to the input, that is n is equal to 0 to n minus 1. Now x2 of n and the remaining part e power minus j 2 pi by n into kn. Now according to this formula, we know that x of n into e power minus j 2 pi by n into kn, this whole thing with the summation is simply known as x of k. We have something similar over here. We have x1 of n into e power minus j 2 pi by n into kn. So according to formula, this whole thing is known as x1 of k because we have input as x1 of n. Similarly, here also according to formula, this whole term will be known as x2 of k. So last step, I will write a1 as it is and this whole thing is known as x1 of k plus a2 outside. Then I will write a1 as it is and this whole term is known as x1 of k plus a2 as it is. Then this whole term is known as x2 of k. Therefore, our property is proved. Thank you.